All right. So when we're looking at word problems that require a system, they're not typically going to state outright, hey, this is a system of equations, now solve this problem. One of the big hints that you're looking for is they're going to give you more than one total so that you have enough information to write multiple relationships. Okay? So when you see more than one total, that's your hint. We're dealing with a system. Okay? What is this first example asking us to find?
How many of each?
Okay? What type of tickets do we have?
The adults and
We have adults and we have students. Okay, so we need some variables. What variables do you want to use? Okay, so A, adult, tickets, and S is our student tickets. And I want to clarify too. It's the number of tickets, right? Because they give us the price, so our variable represents the amount of the tickets, okay? How many were sold. Okay, so what's one of the relationships given between the adult tickets and the student tickets?
together
Okay, the numbers combined, the number of adult plus the number of students equals 102. Okay, so there's one of our relationships. What's the other one?
the total they cost.
Okay, so if I wanted that total cost, that's $1,932, how would I calculate that cost?
A
21A plus 15S. Awesome. Okay, so now that we have our two, what can we do to solve?
solve for one of the either A or S and then
Cool. What should we do to solve?
like for example get the S on the other side.
So we have A equals 102 minus S. That allows us to substitute in for A over here. 21 times 102S plus S equals 92. Okay. What is 21 times 102? 42. Okay. Minus 21S plus 15S equals 92. All right, now what?
Subtract we got
Okay. Subtract. Do you have any like terms?
yeah.
So what does that give me? -6. Okay. And then 1932 minus 2142. All right. So S equals 35. Yep. Now I need to find A.
You put in the second one and then you like
In this one?
yeah.
Is that going to be the easiest way? This one's going to be way easier, right? If the total of the two tickets has to be 102, it's going to be way easier to plug it into. Can you do the other one? Absolutely. But we're racing the clock in this case, right? So All right, we get the number of adult tickets and we get the number of student tickets. Now, be very, very careful. We used variables that kind of made sense for what we were talking about. A for adults, S for students. Okay, those variables make sense. But if you're using generic ones like X and Y, make sure you identify and define what each variable represents. Because I guarantee on a multiple choice question, one of the answer options will say 35 students and 67 adults, and another answer option will say 67 students and 35 adults. They'll switch it, okay? So if you're using just X and Y, make sure you know X represents this thing, Y represents this thing, so that when you're trying to pick out your answer options, you're assigning the right quantity to the correct value. All right, we look at B. We're just trying to find the inequality, or the equation, the system of equations that models this scenario. When you're looking at all these different options and they're very similar in their structure, the easiest thing to do is start to eliminate ones that it can't be. It's going to kind of reduce that cognitive load a little bit more and make it easier to identify what the correct answer is without getting overwhelmed. All right. So when we look at this first sentence, this allows me to eliminate half my answer options right off the bat. We're able to eliminate which ones? We can eliminate C and A. I'm sorry, Y. So Y, C, and A can we eliminate? Yeah, exactly. The bagel is $1 more than the coffee. So we have to add $1 to the coffee in order to get the bagel. All right. Now we just have to compare the second equation because the first two are the same in both of those options. So now looking at the next part, is it going to be B or D? Why?
Because the 4 is for C.
Good. 4 is for coffee. C makes sense as the variable for coffee, right? And they tell us C is the variable for coffee. 4 is not the coefficient for B. And then likewise, $6 for the bagel. That matches $6 for the bagel, so we know it has to be answer option D. All right, so kind of eliminating some of those can reduce some of that overwhelming. These are all very similar looking. What are we trying to find here? Yep, how many vehicles can hold 7 people? So we need some variables. Give me some variables. Hold on, we need variables first. Okay, let's define them. What is X going to represent? The people? Okay, the vehicle that holds 7. So vehicle that holds 7 people. And then what is Y going to represent? The vehicles that can hold 5 people. Okay, because those are the two things that we're comparing. Vehicles that hold 5 people and vehicles that hold 7. Okay, you can label them X and Y, large and small, van and sedan. Okay, as long as you understand which one relates to what. Okay, so now we can go into our relationships. Okay, so what's one of our relationships that we'll be able to model? Okay, X plus Y equals 7. Why X plus Y equals 7? There's 7 vehicles in total. So the number of 7 passenger vehicles, the number of 5 passenger vehicles added together gives us 7 total vehicles. All right, another relationship. Here we go. 7 people per 7 passenger vehicle. 5 people per 5 passenger vehicle gives us 21 passengers total. Now, do I need to solve for both X and Y? No. Which one is the question asking for? X. So that's the only one I care about. So solve it in a way that gives you the value of x and gets rid of y. What could we do?
The first one will put y equals.
Yeah. If we rewrite this to y equals 7 minus x and substitute it in, we're left with x. Y is gone. I don't care what y equals, so I don't need it anymore. It's done its job. Does that look good? Does that look good? Yeah. I tried to trick you. You guys are too smart. Okay. Now what? So what do we get on the right? Good. And x equals 3. Perfect. Okay. And again, I don't care what y is. I just want to know how many 7-passenger vehicles. X is the number of 7-passenger vehicles. X equals 3. So there are 3 7-passenger vehicles. Now on D, we're writing a system of inequalities. So remember, that's our less than or equal to, greater than or equal to, less than or greater than. So instead of an equal sign, we have one of our 4 inequality symbols. All right. What I want you to do is I want you to read through this, take a minute, and tell me how many relationships and how many inequalities we will write based on this scenario. How many relationships will we be able to write? How many totals do we have? 2 totals? Give me 2. Okay, so we have at least 30 prizes. What inequality would represent that? Less than, equal to, greater than, equal to, less than, or greater than? Greater than or equal to 30 prizes. 30 needs to be the least value, at least 30. So 30 has to be the smallest, anything else has to be greater. So we want an amount greater than or equal to 30. Okay, what about no more than $100? That is less than or equal to $100. Do we have any other totals? Other relationships? We want at least 15. What's that going to be? Greater than or equal to 15. Anything else? And at least 5. Greater than or equal to 5. So how many relationships do we have then? We have 4 relationships. Okay, 4. Now let's build out the left-hand side. How do we get greater than or equal to 30? What does 30 represent? Number of prizes, right? So if I say 15x plus 5y, what does x represent? The number of small prizes. And then y is the number of large prizes. So if I were to say, all right, I need at least 30 prizes. So let's take the number of small prizes I buy, then multiply that by 15, and then add it to the number of large prizes I buy, but multiply that by 5. Does that make sense? I'm taking the number of small prizes I buy and I'm multiplying that by a bigger number. And then I'm multiplying the number of large prizes also by a number and saying the total that I buy has to be greater than 30. Doesn't quite make sense. I just want the total number of prizes I buy, when I add them together, to be greater than or equal to 30. So how do I get there? For small prizes and the number of large prizes, I go buy them. I need at least 30 of them. What am I adding together? Okay, so what's that expression going to be then? What represents small prizes? And what represents large prizes? So what expression would represent me combining x plus y? That's it. X plus y. Remember, the 15 and the 5, those are different totals, right? Those are other constraints that I have to have, not necessarily a coefficient or a constant in any other part. Okay, those are different totals. So now I have another constraint. My cost needs to be less than or equal to $100. So I need an expression that would be used to calculate the cost. 2x plus 5y, because those are the costs associated with each of the prizes. So x and y is the amount of prizes. The amounts added together has to equal the total amount. 2 and 5 are the cost of the prizes. So the total cost has to be less than the restriction. Now we have another restriction, 15. What is the restriction on 15? Just x. X has to be a value of at least 15. And then greater than 5 has to be y. So these are our 4 relationships. The sum of the prizes has to be at least 30. The sum of the cost has to be less than 100. I have to have at least 15 small prizes, and I have to have at least 5 large prizes. And I'm going to draw a really rough sketch here. If you were to try to find something that would satisfy this condition, you're going to need a graph because there's a lot of shaded regions. We're going to talk more about the shaded regions tomorrow on the next part. But basically what we would have is 2 graphs. So one like this and one like this, okay? And so we'd have a shaded region kind of down here, and then another shaded region up here, and their overlap is this area in the middle. That's these first 2 parts. So anything in this area is going to satisfy both of these inequalities. Well, then we have these 2 other restrictions where x has to be greater than a certain value. And so we've got this shading on the right, and y has to be greater than a certain value. So then we've got this little section here in the middle, which is any point in that area would satisfy all 4 of those conditions. And so if we needed to find something that satisfied, we would have to graph this to see what options are included in that area. Okay? Questions, comments, concerns, queries, conundrums?